Hi all, this lesson is on hypothesis testing comparing two means now, and this is also called the independent two-sample t-test. The last lectures we were comparing mu or p to a constant value. This time we are comparing two group means to each other. This is one of the most common hypothesis tests used in real world. Just like the other hypothesis tests, there are three possible sets of hypotheses. For all of them, the null hypothesis is mu1 equals mu2, which just means the mean of group 1 is the same as the mean of group 2. The alternative hypothesis is either mu1 is less than mu2, or mu1 is greater than mu2, or mu1 is not equal to mu2. And just to review, that not equal to is called the two-tailed scenario, and the other two, the less than or greater than scenarios, are the one-tailed test. And then I just want to point out that in StatCrunch, they write the hypotheses a little different than how they look above, so they look different than this, but it is equivalent. It's an equivalent form. So mu1 equals mu2. If you just subtract mu2 from both sides, you get mu1 minus mu2 equals 0. And then again, for the alternative hypotheses, if you subtract mu2 to both sides, you'll have mu1 minus mu2 is greater than 0. And same thing for the less than. They mean this essentially the same thing, just how StatCrunch writes it. So don't get confused when you see the StatCrunch output. So let's look at our first example. We want to test the conventional wisdom that it is beneficial to eat breakfast the morning of a big test. So we take a sample of high school students and randomly assign them to two groups. One group eats breakfast before taking a sample SAT, and the other group won't eat breakfast. And there is 28 students in each group. It isn't necessary to have the same amount of students in each group, but that's how this example is set up. So the results are that the group that didn't eat breakfast had a mean sample of 418 with a standard deviation of 56. And the group that ate breakfast had a mean score of 438 with a standard deviation of 49. And using a significance level of 0.05, we want to test whether the students who ate breakfast score higher than who didn't eat breakfast. So we're going to label the two groups, group 1 and group 2. And just to keep it simple, I usually label whatever the first group listed in the problem as group 1. So group 1 in this example didn't eat breakfast, and then group 2 did eat breakfast. So the null hypothesis is always, again, mu1 equals mu2, or mu1 minus mu2 equals 0. And the alternative hypothesis requires some thinking. We want to test whether group 2 has a higher mean than the students in group 1. Well, that's the same as testing whether the mean of group 1 is less than mean of group 2. Which means that the alternative hypothesis is just mu1 is less than mu2, which may seem counterintuitive since we are asked whether students in group 2 had a higher mean. So you may expect the greater than sign, but since mu1 is on the left side, the inequality is mu1 is less than mu2, which is the same as saying mu2 is greater than mu1 if you put mu2 on the other side, but it's just how the problem is always set up, is mu1 is on the left side. So now we have our hypotheses, and then for all of these, I'm just going to ask you to do them in StatCrunch so you'll never have to do them by hand. And below right here is the StatCrunch output, which is in the example videos I show you how to generate this output, and all we need really from this is the p-value, and the p-value here is 0.0927. So then we state the rejection rule and then the conclusion. So since our significance was 0.05. We reject H naught if p-value is less than 0.05. And then in this case, our p-value is greater than 0.05. It's 0.0927. So we fail to reject H naught. There is insufficient evidence to conclude that, on average, people who eat breakfast score higher than those who don't. So that's that for that example. And just a note, previously we had to decide whether to use T or Z. For this section, we will only use T. In real life, we really never know sigma, and for large samples, Z and T are essentially the same. So we will always use T for this section. Okay, so here's another example. We have an oatmeal company that wants to be able to advertise that eating oatmeal every day for a year lowers people's cholesterol more than Lipitor. So they take a sample of people and randomly assign them to two groups. One group eats oatmeal every day for a year, while the other group for a year takes a low dose of Lipitor. So here are our data points for each group. They specify that some people dropped out because they were in the oatmeal group. So the samples are not equal, but that's okay. We don't need equal samples. So each data value is the number of points a person's cholesterol dropped that year. So for instance, this 12 means that that person's cholesterol dropped by 12 points in the year. So the null hypothesis is that the means are equal, and the alternative hypothesis is that the oatmeal group has a larger mean than Lipitor group. So here are the hypotheses. So if we call oatmeal group 1 and Lipitor group 2, these will be our hypotheses. So mu1 is the oatmeal group's mean, and then mu2 is the Lipitor's group's mean. So then we get our p-values again from StatCrunch, our p-value from StatCrunch, and we have 0.0039. They didn't specify the level of significance, so we will just use 0.05 by default. Therefore, reject H naught if p-value is less than 0.05, which our p-value is, it's 0.0039. So therefore, we reject H naught. There is sufficient evidence to conclude that oatmeal lowers cholesterol more than Lipitor. And then the last thing I want to mention is in the output you see there's a note that says without pooled variance right here. Well, in StatCrunch there's an option for pooled variance, and I show you in the example videos this option. Well, when you're doing a 2-sample t-test, there's always this option of whether you want to pool variances or not, and you would pool variances if you want to use the assumption that the two group variances or standard deviations are equal, but we don't want to make that assumption, so we will always uncheck this in StatCrunch. We're never going to assume that there's pooled variances, so you don't have to worry about this. Just uncheck it in StatCrunch, and that's all. So let me know if you have any questions.